Welcome back, everybody. In this section, we're going to talk about what happens when magma or lava cools down. It makes this thing called an igneous rock. Before we can go further, though, we need to lay some background knowledge. Ask the question, what does it look like inside a volcano? Now, we're not going to start with the volcano up here, though. We're going to start down here, deep in the earth, with the batholith. So this is our liquid rock reservoir deep within the earth. It has these connecting tubes to other places. You might think of it like a plumbing system. And if these tubes cut across the sediment, they're called dikes. If they run alongside the sediment, these are called sills. You might have an intermediate magma chamber here called the stock, kind of the on deck, the immediate resupply. And you can have this final smaller magma chamber here, which is the central one for the volcano itself. Now, how does this actually get to the surface? It travels through these long, skinny things called volcanic necks. What are the layers here making up the volcano? These are going to be the dried remains of previous lava flows and these things called pyroclastic deposits, which we'll talk about in a bit. So then, to know what is happening with the formation of an igneous rock, we have to figure out, are we forming it down here? Are we forming it up here? What is happening? Now, as this magma or lava cools, it crystallizes and it forms an igneous rock. And our key question now is, how do we classify these? How do we tell one apart from another? Well, we're going to talk about chemical composition later. For now, we're going to worry about how the grains look, how they feel, this thing called texture. And the key factor is how quickly the magma or lava cools. If it cools quickly, then we get small crystals. If it cools slowly, then we get big crystals. What happens if the rock cools slowly? Well, in this case, we get something called a phaneritic texture. Phan means visible. It means you can see it with a naked eye. We're going to have large interlocking crystals. You might hear these called plutonic, after Pluto got out of the underworld, or intrusive rocks that are inside the earth. They've intruded into the rocks around them. These are going to crystallize below the earth's surface. So then on our diagram here of the volcano and the deep magma chamber, we're going to be looking deeper into the earth, have things like gabbros and granites. What happens though if the rock cools quickly? Well, in this case, we're going to get something that looks like this. The crystals themselves are too small to be seen with a naked eye. We call this an aphanitic texture. So the other is phaneritic. This one is aphanitic. A is not, phan is visible. You can't see them. These are going to be associated with volcanic rocks, things that form on the exterior of the earth. Call these extrusives above the ground. You get tiny crystals. You imagine a lava flow cools down. This is something like what you might see. So then we're going to be here on the surface. Our extrusive rocks are going to be the ones that cool quickly, things like basalts and rhyolites. Now, sometimes it happens that the rock cools slowly and quickly. Now, not at the same time. What we have is a two-stage cooling process. So we are deep in the magma chamber. It is cooling and crystallizing slowly and building up this layer of crystals at the bottom. And then the volcano erupts and all the material on the inside comes out and finishes the cooling process very, very quickly. So then what we have is this collection of large crystals and small crystals all mixed together. It's called a porphyritic texture. So on our diagram here, you might imagine that this was forming deep within the earth, and then later it comes up and starts to do the rest of the cooling process here at a shallow depth. This is going to be our porphyritic rock. And you might notice this one is number 4. That is going to be the first number in the access code. The first digit is 4. So you might imagine you're out in the field somewhere, you look at a rock on the ground, you pick it up and you see that it has crystals of one size, this big size, and then it also has this finer ground mass of small crystals. Same with this one, you have this large crystal size and small crystal size all mixed together. Well, now you would know that this is a two-stage cooling process. First slowly and then quickly. Now, what about everybody's favorite igneous rock, Obsidian Dragonglass here? This actually forms extremely quickly. So quickly, in fact, that there's not time for any kind of crystals to form at all. Instead, you have this glassy texture. No crystals on the inside. It is amorphous, structureless, without form, completely disorganized top to bottom. On the other hand, sometimes you have a case where there is some kind of a lava and it has all these gas bubbles trapped in it. And as it cools very, very quickly, those gases escape. They escape and pop, and you have these sort of bubble-shaped indentions, these cavities on the surface. These little bubble holes are called vesicles, and so the texture is called vesicular. Alright, so I said we were going to leave chemical composition for later, and now we're here. The key factor, just like with magmas and lavas, is the silica content, how much silicon and oxygen is inside the rock. You can have something with a lot of silicates in it, a lot of silicate minerals. We would call these felsic. Going to be low density, light in color, a lot of aluminum, sodium, and potassium. Tend to be white or pink. You think of, your classic granite out of the textbooks, right? That's what it's going to look like. On the other hand, or other extreme, skipping ahead, we can have something that is poor in silicate minerals, so not a lot of silicon or oxygen. Going to be a lot more magnesium, calcium, iron, darker in color, more dense. These are going to be mafic. So we have felsic on the one hand, we have mafic represent with black, and then we have the intermediate rocks, which are kind of in between the other two. So now, if you and your buddies are out hiking and you guys find something that looks like an igneous rock and has these massive crystals, you would know something about where the rock likely formed. On the other hand, if you find this stuff that is really, really dark in color and there's no visible crystals at all and there's all these little gas bubbles, you know something about how that rock formed, you can put it all together and work backwards from that rock to the environment that it came from. Okay, in the next section, we talk about extrusive hazards, aka what happens when the volcano blows up.